Good morning, everybody. Today, I'd like to go over a couple of new projects that are in public beta from ARM, so we can see where their tools are going over the next few years. So the first one I'd like to discuss is their new development environment called Keil Studio. So this is a cloud-based tool that allows us to develop for Cortex-M microcontrollers, either as it's both a cloud and also a desktop-based tool. One thing I'd like to be really stress from the beginning, that this is the next generation tool that will ultimately become the mainstream tool in place of MDK. But that won't be for a number of years yet. So if you're using Microvision at the moment, this is just to give you an idea of what's coming down the line. But certainly the support for Microvision, the existing Keil tools, is not going to go away anytime soon. So just relax and see the new features that are coming. So at the moment, the Keil Studio is in a public beta. So it has a limited range of functionality. It does give you an IDE development tool, but is best currently suited for what would be called the discovery phase of a project, where you're selecting a microcontroller or want to try out different examples on a variety of evaluation boards. So at the moment, it provides support for a limited range of boards, but these are going to expand fairly rapidly. So we can begin by selecting our device and evaluation board that we want to use. We can then directly jump into Keil Studio, and as it's cloud-based, all of the software is set up and ready to use. So you can just open up an example and start experimenting, expand the code. And underneath the Keil Studio, the project can be exported to existing desktop tools. So if you're using MDK, anything you generate in Keil Studio can then be downloaded and imported into Microvision. And then we can further develop that code to run on the evaluation board. And then, as necessary, we can migrate to our own dedicated hardware. So this gives us a new experience that you can experiment with and just sort of keep an eye on to see how it's developing over time as well. Now, as well as providing an IDE, compile and debug environment, the Keil Studio is being developed to cope with new technologies that are emerging. So things like the Internet of Things and also machine learning applications as well that are going to be able to run on small microcontrollers. Now, these are significantly more complicated than our traditional embedded development environment. So we need new techniques and new ways of approaching developing for IoT and machine learning. So in our traditional development environment, we generally create the software in an IDE. We can download to a target, we can test that with a debugger, and then we can go around the loop again. So everything's running basically on your desktop. But where we come to IoT, machine learning development, then that loop can be a lot more complicated. So typically, what we'd like to have is, certainly for IoT, is to have a fleet of devices in the field, so that we can develop our software and then deliver that software over the air into our devices for testing. And we'll be able to monitor those devices as they're running as well. So we can get back statistics, we can see how they're interacting with cloud services. We can then further develop the software and deploy that again into our fleet of devices. So this gives us an approach to continuous delivery, where we're actually running the full system in the field as we're developing it. And this gets more important for machine learning. So here, as we have our devices out in the field, we want to gather data. We want to develop our machine learning model and refine that. We then want to be able to deploy that out to all of our devices so that we can also monitor those and gain analytics about how they're performing. And then we want to gather more data, place that into our model, test it and deploy it again. So again, this gives us a much more complex development loop, which traditional tools are beginning to struggle with. So the point of Cloud Studio is to provide these new forms of development and support them as time goes on. We also want to have a development tool that more naturally links up to version control systems and things like GitHub, but also continuous integration servers, so that as we commit code, we can run it through a farm of tests, and provided they all pass, then we commit the code. So although we can do this with desktop tools, we want to make this a much more natural and painless way with the Keil Studio. So there's a number of challenges that development tools are going to have to come to terms with over the next few years. So as time goes on, we'll see these features start to emerge within the Studio tools. So the key advantage of using a cloud-based tool, it's all set up and ready to go. You're using it as a service. You have your own workspace, and that's backed up and maintained for you. As I mentioned, we'll be able to do software updates over the air as a natural part of the tool. So we can deploy code out to a fleet of devices. We can monitor those devices, collect data from them, so that we can go around these more complex development loops. Then finally, we'll have continuous integration and also much more emphasis on setting up tests and acceptance tests within the tool chain as well. So again, there's a URL at the bottom there. So all of these slides will come out to you afterwards. But here there's a guide to using the MDK ARM Studio. So although it's, again, a cloud-based tool at the moment, it will also be available as a desktop tool. So our initial use cases, at the moment, it is very much in the early stages of a beta release, a public beta. So you can set up and use existing projects and existing evaluation boards. I think there is some support for setting up custom hardware, but that's probably a little bit limited at the moment. It imports a lot of IP from the existing ARM Embed project. So this is another cloud-based development tool chain. But the Keil Studio, as well as adding a more sophisticated development environment, also adds a means of doing browser-based debugging as well. So we can download a code, run it on a board, and debug it like we would with a desktop tool. ARM is also very keen on their ecosystem. So they're currently engaging quite a number of partners to allow them to develop plugins for this tool as well. So again, we'll have a number of sophisticated third-party additions to the tool as well. So at the moment, as I said, it's public beta. You can, if you have an ARM login ID, you can join it and start using it. So it allows anyone to access it. You can develop projects and build and I believe use the IP as well. It's fully compatible with all the existing CMSIS standards. So anything that you do develop in there, you can move out to third-party tools. So Keil Studio uses the CMSIS build project format. So this is a standardized project format that can be imported into a range of third-party tools. So if you're using Microvision, great, well done. But if you're using another tool, provided it supports this format, you can bring your project directly into it and continue working. So over time, so as I mentioned, we're in a very early phase at the moment. we would expect to see the Keil Studio, its features and its functionality ramp up. Really, we're talking still in terms of years. So if you're using the MDK at the moment, that's going to stay as the mainstream development tool for quite a period of time. Until the features in Keil Studio become more and more compelling, and we reach that crossover point where if you're starting new projects, really should be doing them in Keil Studio. But as I say, this is a way off, and at the moment, really the Keil Studio is sort of a project that you just want to keep an eye on and experiment with. So when that crossover point comes, you've got some background experience of it. So to have a look at through some of its features, we'll go through these fairly quickly just to have a quick look at the IDE. So this sits within a browser, and it gives us a sophisticated project environment. It's available as a black screen or white screen, depending which light or dark mode, depending which format that you like. Initially, we can select the evaluation boards from a particular manufacturer that we want to work with. So this will show you all the available examples, the support that's available for the board, its data sheet, etc. And then we can, from there, we can jump directly into the IDE to start building and using the project. So this, the IDE is based on an open source IDE called Thea. So this allows it to work desktop or browser. And it also incorporates an editor called Monaco. So this is also, I think, based on the Visual Studio Code that's released by Microsoft. So it gives you a similar experience, but it's much more in tune with embedded systems development. So within here we have Project Explorer, Editor, and Debugger, Build and Source Control. So within the Project Explorer, we can manage our project, open files. We also have control to build, run, and debug. When we create the project, we can select the evaluation board. And if that's then plugged into the PC, this will be available within the cloud-based tool. So this gives us a direct link to our hardware for download and debugging. So I believe this is a first for a cloud-based tool. So the debug interface is the CMSys DAP interface. So this is a low-cost debugger that's built into a wide range of evaluation boards. So we can plug into anything that's CMSys DAP compatible and then be able to download and debug. In terms of debug adapters, the U-Link Plus also supports a DAP interface. So the ideal debug adapter to use with this would be a U-Link Plus, and then you can go and download and debug onto your own hardware. When we create a project, these are all CMSys compliant, and as I mentioned, they're built in the CMSys build project format, so they're easy to export out to any other additional supporting tool. Within here, we also have support for the CMSys pack, CMSys driver, so that these, and also the interesting is CMSys virtual IO as well, which we'll talk a little bit more in the second half of this presentation. So in here, this follows very much the development for, process that we have within Microvision at the moment. When we compile projects, underneath the Keil Studio is the ARM version 6 compiler. So this is a very new code base, very efficient compiler, which is also safety rated. And behind this is a powerful cloud computer. So as you start to build larger and larger code bases, the actual compile and link time becomes incredibly fast. So this is quite a nice feature of using a cloud tool, that you have a really a very fast build process. As a more natural part of the tool as well, we include source control. This will also link up typically to GitHub and be able to trigger continuous integration servers as well. So we can set up a whole bunch of tests which we run every time we commit code into our source control system. Again, we have, as I mentioned, the debugger. This is again runs within the cloud-based server. So this provides us run-stop debugging, but will also include features from the microvision debugger, like the event viewer, so that we can get real-time information on the fly. So when you're debugging things like an RTOS, you'll be able to have a graphical view of the threads. You'll be able to get real-time updates of variables and your own instrumentation within the code as well. So this gives us the basis for a very sophisticated debugger. Now, in the other project that I want to cover today is the ARM virtual hardware. Now, in the early days of microvision, the debugger included a software simulator that simulated the ARM processor and also the microcontroller peripherals as well. So in the early stages of a project, this was an incredibly useful tool that allowed you to build download code and experiment with it within the simulator before your hardware is actually available. Unfortunately, as the number of Cortex-M microcontrollers exploded, maintaining that simulator just became impossible. You couldn't build the simulation models fast enough. So although the legacy ones are still in the tool, and there are also a number of core simulators within microvision, simulation is not a key feature of the tool. So this new project creates an Amazon machine image that runs a simulation of Cortex-M processors. So the first one is based on the Cortex M55, with their neural processing unit, their micro neural processing unit for machine learning applications. So this gives us what they call their cornerstone simulation model of the processor and its surrounding IP. And in addition, there's some virtualized hardware that allows you to develop a full application. So this includes support for a range of peripherals, but also some streaming virtual I/O for BSD socket type connections, audio, and other types of streaming data. So this allows us to create the simulation of an IoT device and run it in the cloud, and indeed run multiple instances of that device in the cloud as well. And this is all then surrounded by developer tools, test scripts, etc. Again, all built within the CMSIS build specification. So here we have the simulation environment. So we have the Cortex processor that can support our application code and various different small footprint operating systems. And in addition to that, we then have virtualization of common streaming interfaces. So for example, I think the first one that they have in there is audio streaming, so for keyword recognition, and also a TCP/IP streaming socket as well. So we can build up IoT systems. We also support for CMSIS virtual I/O, so we can simulate certain peripherals that are on the device. So GPIO pins, ADC, DAC, and also MEMS sensors like gyroscopes. And we've also brought in very useful parts of the Keil debugger, so the event recorder. So this allows us to send instrumented data up to our debugger so that we can build a visualization of how the system is running. So from that model, we have our virtual drivers, which we can run in simulation. We can then export that model to an evaluation board with matching hardware drivers, so we can run on a real device. And then we can migrate that out to our custom hardware with additional drivers that build up the full system. So this virtual hardware gives us a very nice way to start development, get working some of the complex peripherals, build the communication stacks, build and test machine learning algorithms, and then slowly migrate that out to our final application. So it's a useful concept, and as I say, it's another project that's in public beta, so you can start to experiment with it now. Also, when we come to testing, it's possible to test your application on physical hardware, but there are always some strong advantages of doing it in simulation. We're not having to program the flash all of the time. We're just downloading directly into the simulation and executing the code. So this gives us a much faster round-the-loop execution time. And then it's also zero cost or very low cost to duplicate the simulation system, so that we can run tests in parallel as well. So that gives us a big improvement in testing time as well. So again, virtual hardware is available, arm.com virtual hardware. So again, we would recommend having a look at that to just experiment with it and trial the system. So it's been a quick run through it this morning, but it's really just to bring your attention to these projects that are within ARM and are developing in the background. As I mentioned, both of them are fairly early at the moment, but they're all free to use and to experiment with. As they go along, we'll be running some deeper webinars to actually show you these in action and how you can take advantage of them yourself as well. So thank you very much for your time today. If you have any questions, please let me know. There is a short survey after this, and we would be very interested in your attitudes to using cloud-based tools over traditional desktop tools as well. So this marks quite a big transition at the moment, and it's very nice to have some feedback from you on what you think about that. So great, thank you very much.